All right, welcome to BioPath Tools for Biochemistry. What is BioPath? BioPath is a website where students and teachers can create and run simulations of biological pathways inside cells. A user can sign in on the top right using their own credentials or with Google Sign-On.
Once signed in, the user has three options. They can view a model that is completed by the instructor under teacher's models. They can view a model and create a model under student models yourself, or you could view the getting started video that you're currently watching yourself. So today we're going to be giving a brief introduction to how a user can use the site by walking you through how to create a pathway, some of the different features you have at your disposal when creating a pathway or when you're viewing a teacher's model, and the different parts of the pathway in case you're brand new to biochemistry. So we're going to start with teacher models, like I said, and we're going to select glycolysis for today. As you can see on the screen, you're created with a molecular pathway. And a pathway is a linked set of chemical reactions that occur within a cell. And that's this whole glycolysis reaction right here. A substrate, which can be either be glycolysis, G6P, F6P, or F16BP, for example, is the input molecule upon which an enzyme reacts upon. And then there's cofactors or enzymes, which are right over here, which is demonstrated by hexokinase, PGI, PFK. And an enzyme is the catalyzer for the chemical reaction. It takes substrates and as an input and outputs products, which for glucose would be G6P and hexokinase for the enzyme. In the screen you can see right here, you have access to a key, which tells you that a green rectangle is a partially filled rectangle, an orange rectangle is a half-filled substrate, a red rectangle is a completely filled substrate, then an arrow is a molecule, and we did it in arrow so that you can see directional movement, whether it's going reversible or irreversible. And then you have the cofactor black circles, which are enzymes, which I previously mentioned. On the screen, you also have access to change the increase or the concentration of enzymes such as hexokinase. So you could increase it and you'll see that it speeds up, or you can decrease it and it'll go down. But you could also view the reaction right here. So you see you have ATP, hexokinase, ADP, and G6P right over here. And you can see that this is the valid reaction for here, marked by green. But also, you can go look at the different individual components. So like for adolase, you can go over here, and you can see where it fits in. Now, if you click back on the BioPath button on the top left-hand corner, you're going to be run back to the home screen where we can examine another useful feature on the website, which is the student models.
Here we can select the pathway to recreate and test our memory. And for this example, we'll use glycolysis. Now, when you load into a student model for the first time, you will see a blank canvas for us to create our pathway. To add a reaction to the pathway, click the Create New Reaction button. And then for our example, which we're doing the glycolysis pathway, we're going to need some ATP, some glucose, hexokinase, ADP, and the last part is glucose 6-phosphate. Well, but let's say we don't remember that it's glucose 6-phosphate. So let's try to create the reaction. But as you can see, it's red because this is actually an invalid reaction because it doesn't exist. But let's say we do remember, and now it's green because it's the perfect, it's the reaction for the first step of our pathway, and it's just a correct reaction in general. Now we can save that, and now it will appear like it did on the teacher models. And you can even change the sliders in here as well. Now let's create a new reaction, but let's say we don't remember all the products and substrates that are associated with it, but we do remember that the enzyme is phosphoglucose isomerase. What we can do is we can click Create New Reaction, and the website will automatically fill all the substrates, products, and it will even know whether or not the reaction is reversible or irreversible, so we can save it. Now, let's say we get a correct reaction like hexokinase, which is actually the first step in glycolysis, but it's not the next step in the reaction or in the pathway. It will not allow us to save this because It is not the actual next reaction. And finally, if you ever need to leave and come back, feel free to do so, because all your progress will automatically be saved, and it is associated with whatever account you signed in for both Google or if you create an account with the website itself. Happy studying.